Welcome to The Explainer. Today, we're unpacking a fascinating, complex, and honestly, incredibly urgent 22-year data detective story. We're going to look at the Brazilian Amazon, but not through the usual lens. We're actually using a massive study recently published in the Journal of Environmental Management that deployed some seriously advanced machine learning to uncover the true, and sometimes shocking, drivers of Amazon deforestation. Okay, let's dive into this, because the results completely flipped my understanding of the Amazon.
For years, if you asked anyone what was destroying the rainforest, you'd almost always get the exact same answers: cattle ranching and illegal logging. And while those are absolutely massive factors, relying on assumptions is a pretty dangerous game when you're trying to save one of the most vital ecosystems on the planet. I mean, if our traditional models are flawed, our conservation policies are just going to fail. We need undeniable facts. To really grasp the stakes here, we have to look at the sheer scale of the crisis. 220,000. That is the number of fire outbreaks that occurred in the Amazon biome in a single peak year during the early 2000s. We aren't just talking about a few isolated incidents. We're talking about an absolute environmental hemorrhage. But the data shows that this destruction isn't just a steady, uncontrollable upward curve. It ebbs and flows, and it does so based entirely on human action. Just track the annual deforestation rates from 1999 to 2020. See that massive, terrifying spike in red for the state of Mato Grosso right around 2004? But notice what happens right after. The numbers absolutely plunge. Why? Well, because the Brazilian government stepped in with strict policies, like the Action Plan for the Prevention and Control of Deforestation. They essentially use satellite monitoring and heavy law enforcement to bring those numbers down. But look over at the right side of the timeline. From 2018 onwards, there's a really alarming resurgence. Basically, the old policies just aren't holding the line anymore. And this brilliantly illustrates the reality on the ground. When we compare fire outbreaks across different biomes, the visual evidence is staggering. Look at how the blue bars, representing the Amazon, completely dwarf the red bars of the Cerrado Savanna. Over the last 2 decades, the Amazon biome just totally dominates the fire outbreak data. In peak years, like 2004, the Amazon literally stood alone as the primary victim of these devastating fires. So if we know exactly where the fires are happening, and we know deforestation is on the rise again, how do we stop it? Well, to answer that, researchers had to address a pretty fundamental problem. Section 1. Flaws in traditional tracking. Missing the full picture. For a really long time, researchers used traditional statistical methods, things like pooled ordinary least squares or OLS regression. Think of this old way as trying to draw a perfectly straight line through a chaotic, entirely unpredictable forest. It really struggles to capture the complex, nonlinear realities of the actual environment. The new way, on the other hand, requires advanced machine learning models that can digest massive amounts of layered, interacting data without oversimplifying the whole thing. Section 2. Enter machine learning, the AI detectives. So to crack the case, researchers actually deployed 5 distinct AI algorithms through this really rigorous pipeline, cleaning the data, testing it, and training the models. Out of all of them, the random forest model proved to be the ultimate detective. It had the highest accuracy, the lowest error rate, and was by far the sharpest tool in the shed for predicting deforestation. But here's the absolute genius part. They didn't just want the AI to spit out a final answer. They wanted it to show its work. So they brought in a technology called explainable AI, specifically a method known as SHAP. Think of SHAP like an interrogation room. It basically forces the artificial intelligence to explain exactly why it's assigning blame to specific variables, breaking down the precise impact of every single piece of data based on cooperative game theory. It's wild stuff. Section 3. Analyzing 16 variables, bringing in the suspects. All right, with the random forest model fully trained and our SHAP interrogation room set up, the researchers fed the model 16 primary socioeconomic and environmental variables spanning from 1999 all the way to 2020. These suspects included gross domestic product, total planted area, rural credit flow, cattle herd sizes, the area of permanent crops, temporary crops, state budget expenditures, and even the political parties of the acting governors. Now, I naturally expected cattle or soy production to be the undisputed prime suspects here. But wait until you see what the AI uncovered. Let's just rewind for a quick second. A major study back in 2009, which used those older linear models, concluded that livestock expansion was the absolute main immediate cause of deforestation. Basically, cattle meant clearing. And that was pretty much accepted as gospel.
But our new AI model, which is processing a much larger, much more recent dataset with far greater complexity, is about to turn that assumption completely on its head.
Section 4. The surprising culprits. A major twist.
So, the random forest and SHAP models analyzed the complex interactions of all 16 variables over 2 decades. And when ranking the absolute top drivers of deforestation, cattle herd expansion only came in third. In second place was the area of temporary crops, so things like soy and corn. And coming in at number 1, the single most influential predictor of Amazon destruction, according to the machine learning model, was actually the harvested area of permanent crops. Now, what's really interesting about this slide is what permanent crops actually are. We're talking about things like acai, bananas, rubber, cocoa, and coffee. Because they have longer growth cycles and don't need to be reseeded every single year like soy does, you might intuitively think they'd be a bit gentler on the land, right? But this finding completely upends those traditional assumptions. The explosive commercial expansion of these permanent crops is currently the most accurate predictor of forest clearing. To see this hidden footprint in action, just focus on the state of Pará. That's the brown area on the middle right of the chart. Since 2010, Pará's permanent crop area has absolutely skyrocketed, even surpassing Mato Grosso to achieve the region's highest harvested area by 2020. And the data perfectly connects this visual evidence to the state's massive historical deforestation rates. The AI wasn't just guessing here, it found the hidden footprint. Section 5, Smarter Strategies, a data-driven antidote. So the AI gave us the diagnosis, right? But it also found the cure by looking closely at state budget expenditures, specifically the money spent on environmental management and agricultural organization. Look at the general upward trend on this chart. Between 2014 and 2020, states that were under really heavy pressure, like Mato Grosso and Pará, significantly increased their targeted spending in these areas. And the algorithm noticed exactly what happened when they did. This is an absolutely crucial point, coming directly from the researchers themselves. Furthermore, our findings indicate a significant inverse relationship between public spending and deforestation rates. It's simple, profound mathematics. When public spending on targeted environmental management goes up, deforestation rates go down. That funding acts as a literal shield for the rainforest. So, what should you actually take away from this explainer? First off, we have to embrace explainable AI as the new baseline standard for environmental tracking. Those old linear models just don't cut it anymore. Second, policymakers must aggressively monitor and manage the expansion of permanent crops, not just focus entirely on cattle and soy. And third, the data proves, without a doubt, that we must increase targeted public environmental spending. You simply cannot save the Amazon for free. And that leaves us standing at a really fascinating intersection of advanced machine learning and real-world conservation. We no longer have to guess what's destroying the Amazon, and we now have mathematical proof of what actually protects it. So the only real question left is this. If an AI algorithm can pinpoint exactly how to save the rainforest, do we have the political and economic willpower to actually listen to it?